Chapter 6, Section 2. This is the third video, and we're going to get into scenarios where we look at actual quantities of things using the normal distribution. Okay, so let's say we have a problem here about PCs, where the average PC is 120 watts, right? And we want to know how many are going to have less than 106 watts, right? Out of 500 PCs. That'll be the quantity we're working with essentially. So this is obviously a probability, right? So 0 point something, right? Question mark, question mark, question mark as to what that probability is. So what percent of computers are 106 watts or less is essentially what this area represents, right? You could figure out the z-score here too if you want. Obviously this is z equals 0, right? Because that's the middle. If we did this, it'd be what? 106 minus 120, right? And it deviates by 6 watts, right? So z would be a negative, right? So it'd be negative 2.3 repeating, correct? Right? All right, so let's figure out this probability here first, right? So if we do that, that would be the normal dot distribution. And we want to do 106 or less, right? Because this always works left to right. That's how the function works. The mean is 6, deviates by, 120 is the mean, deviates by 6. I'm going to add it all up, and there we go. True. There we go. Okay, so that's the probability of that little area over there is about, a little less than 1% basically. So this times the 500 computers, right, is this many number of computers. But the thing is, you can't really have that many computers, so we'll round that up and we'll say 5 personal computers essentially, right? Okay, so essentially what we did was we figured out the probability of this area, right, which is about a little less than 1%. So a little less than 1% of computers fall into 106 watts or less, essentially, right? Which is going to work out to about 5 computers out of 500 to actually be the true quantity of computers. Okay. So that's using the probability to figure out the number out of a quantity. Let's look at a couple other different scenarios here. Let's say at an Ivy League college, we want to score on a test and be in the top 10%. The thing is, if I just put, 10% into the spreadsheet and do the distribution or the inverse, that's not going to give me the answer. It's going to give me the first 10%, which is not what I need, right? So I actually need to calculate 90, right? 0.90 because the computer works left to right when it does the calculus using the functions essentially, right? So this is actually some number of points, right? Some number of points. Okay, as to what that z-score is, we don't really care. So we want to invert this area back to an actual value, right? So we're going to invert it essentially. Okay, so we're going to do normal dot inverse, right? So we're going to take the 90% and invert it back to an actual value. So the mean is 200 and the deviation is 20 points. Okay. All right, so we get 225.631. It keeps going, obviously, if you bring it all out, but that's not really going to matter, right? So what we're saying is this line right here, right? Come on, pen. Is 226.631 ... but you can't get that number of points. We're going to assume you can only get a whole number of points. So you either can get 226 or you can get 227. Well, if you want to be within the 10%, top 10% of students, you need the 227, not the 226, right? So essentially you want to invert the area back to a quantity, or the x-axis, right? You can call it the x-axis or the points axis, wherever you want. It's just not z because we're not using standard 0 and 1. So we want to be greater than, that'd be 220. Did I calculate wrong here? 90. Oh, that's 225. I'm sorry. 225. Okay. So that was 225. 225.631. Right. I'm sorry. So therefore, this is 225, this is 226, right? So you need to be 226 to actually be above the bar, essentially. So any score higher or higher, because obviously if you get 227 or 228, you'd also be fine there. Okay, I didn't look at how I transposed numbers in my head there. All right, let's look at a different scenario. So another one is, what if it's in between, right? So before, if you just took the 10% and put it in, you would have been wrong, right? So you have to think about how the computer works. And again, if you want the middle 60% of people, blood pressure, if you just put in 60%, that's not also correct, because also that would be two numbers, not one. So the middle 60% is going to be 30% either way from the average, right? Which is 120 milligrams of mercury, right? Okay, and deviates by 8. So from here to here, right, is 0.20, correct? Because 30, right, plus 20 is 50, correct? So from here to here, right, is your 50 plus 30, which is your 80, correct? Okay, so you actually have to calculate two different things here to be able to get to the x's. Okay, so we want to normal dot inverse, because we're inverting the 20, right? Because it was a 120 average blood pressure. It was deviation of 8, correct? And we want to invert, normal invert, okay, 80%, comma, 120, comma, 8. And there's our numbers there. All right, so we have to think about our values here. So we have a 113 point something and a 126 point something. Okay, so let's go to our picture here. Okay, so this is, come on, pen, 126.7 dot dot dot, right? Which doesn't really matter what those are. And this is 113.2 dot dot dot, and those don't really matter what they are also. So I'm either 127 or I'm 126, right? Because you can't be this partial, we'll say, for blood pressure when it counts by whole numbers, right? So obviously I need to be the 126 on this side, correct? So I'm either 113 or I'm 114, right? Well, like 113 is on the outside, so 114 is on the inside, so 114 would be the answer. So 114 to 125 would be our correct values, right? Because that would be the inside or the middle 60% of values, essentially, correct? Come on, pinwheel of death, please don't do that. There we go. That is not what I want here. There we go. Okay, IQR is the last thing, right? So remember IQR in the box plot section, right? So let's say we want the IQR, the middle 50%, which is what that's going to tell us. What does it mean? The middle 50% of values, right? So smartphone users between 13 and 55 years of age are approximately normally distributed with a mean of 36.9 and a deviation of 13.9 years, right? So you want to figure out the quartile 1, right, and quartile 3, right, which is the 25th, right, and the 75th, correct? That's what we want to know. Okay, so let's go to our spreadsheet here. So we're going to get normal dot inverse. So the 25th and 36.9 years is the average with 13.9 years, right? Okay. And then we have normal dot inverse 75, comma 36.9, comma 13.9, right? All right, so this is obviously Q3, and this is obviously Q1, right? So if I want my IQR, what I have to do is Q3 minus Q1, and that is the number of years, essentially, that represents the interquartile range. Okay, so let me copy that over. Right. All right, so our middle 50% is what this represents, essentially, right? So this is the middle 50%, essentially, boom, boom, of the age of these people using cell phones.